Bismillahirrahmanirrahim. Welcome to Glenrich Maths. Today, our topic is integration. We are going to solve an integration problem from question paper 9709/32 for the session October-November 2024. And you can see on the question paper I have written my WhatsApp number so that you can let me know which particular question should be solved, which will benefit you. So please let me know through WhatsApp the problem you are facing while solving any particular question. So let's see today's question. I have already solved question number 11, and now I am going to explain in brief how I solved this. Question says let fx is equal to 2 e raised to 2x over e raised to 2x minus 3 e raised to x plus 2. Find f prime x means derivative, and hence find the exact coordinates of the stationary point of the curve with equation y equal to fx. So the clue word is actually stationary point. Look, stationary point, whenever the word stationary point mentioned, we will have to find out the derivative. And in case of stationary point, or it may be written as maximum point, minimum point, then first of all we will find the derivative, and derivative must be equal to 0 in case of stationary point or maximum point or minimum point. So we have already decided that we will have to find the derivative. So let's write the question I have written here. Y is equal to 2 e raised to x over e raised to 2x minus 3 e raised to x plus 2. This is what the question is. Then we have written derivative d over dx of y equal to. How to write this? There are two functions. One is numerator, the other one is denominator. Let me show you. If the function is given like this, then let's say we are given a function y is equal to u over v. How to solve this? The derivative of this will be derivative of dy over dx is equal to, first of all we will write the denominator is v should be written, then we will write d over dx of u minus, then u, just reversal of that, u into d over dx of v. Then what will happen to the new denominator will be squared. So what is this? The easiest way to memorize this, first we will write the denominator should be written first, then there comes derivative, after that reversal, then u will be written and derivative of b. So remember the easy technique, I always follow this. You will have to remember that it starts with v, it starts with the denominator or the lower function. Okay, so first we write v, then derivative of the other one, again we write u and derivative of the other one. So let's see how our solution is. This is our solution. As I have told, first of all we write the denominator, I mean the second function is this. Okay, v has been written, I have written here v, then derivative of the first function. Okay, minus, now this is the reversal, the numerator has been written, then d over dx of the second function. So once again I am repeating that always we write the denominator first. Okay, then derivative of the numerator, then reversal, just reversal. After that, look at this here. First of all we will write the derivative of this function. Okay, because this is required to be differentiated. So how can we differentiate this? We, this is all about exponent. Look, exponent is here 2, if 2 multiplies this 2 it is 4. Okay, then the exponential function remains unchanged, not in all cases. Remember, this is only for e raised to, if it is Euler number then the function remains unchanged. So we have left the function unchanged, and the this 2x has been differentiated. Actually, if we differentiate this, d over dx of 2x is equal to 2. So the exponent should be differentiated in case of Euler number. If it is any other exponential function, it will be different. Okay, so remember, if this is Euler number, then only the exponent will be differentiated. Well, if exponent is differentiated, we got 2, then 2 multiplied, there is already another 2, so multiplying this 2 by 2, that is 4 e raised to 2x. So differentiation has been completed, and this is absolutely unchanged. We left it unchanged over here. After that, again we will apply the same method of differentiation. If we differentiate e raised to 2x, then it is already we have differentiated that these two, this should be differentiated. Okay, we will differentiate the exponent. In case of Euler number, please don't get confused with other exponential function. Only in case of Euler number, the exponent will be differentiated. If we differentiate 2x, it's 2, so we have written here just 2. Okay, not this two, actually this is the unchanged part. This one, there is no differentiation related to this is just unchanged. Okay, this is unchanged part. After that, if we differentiate this, it is as I have told, the differentiation derivative of 2x is 2, so we have written 2. And the Euler exponential function, in case of exponential function, it remains unchanged. So 2 e raised to 2x minus, here also it's same as I have told, that the exponent should be differentiated. If we differentiate x, this is 1, so 3 ones are 3, and the function at is, and the derivative of any constant number is 0. That's why we avoided that one. Let me go backward. And what about denominator? Denominator will be square. Look at this. As I have told, denominator is square. We have written here whole square. After that, we have done the simplification. Let me erase this unnecessary part so that you can see better. We can see that 4 e raised to 2x is common. I mean, e raised to 2x, here there are 4 and here there are 2 e raised to 2x. So we have taken 2 e raised to 2x as common. If 2 e raised to 2x goes away from 4, there remains 2. That's why these 2 will multiply. These 2 will multiply whole of this function. We have written 2 e raised to 2x, and 2 3s are 6. This one is 2 e raised to 2x, and then 2 3s are 6, and 2 2s are 4. We have written here 4. This is about the first function. Then minus symbol. Here also 2 e raised to 2x has been taken as common. Here we have taken this as common factor. So if it goes away, there remains only simply 2 e raised to 2x, and minus it has been turned to plus 3 e raised to x. And denominator, we didn't even touch the denominator because this is of no use to us. That's why we left it. So ultimately, if we do simplification, look at this. These 2 e raised to 2x can be dissolved by this. So what does remain there? 6 e raised to x plus 3 e raised to x. If we subtract 3 from 6, there remains 3 e raised to x and negative, and this 4 is absolutely unchanged. So we have got 4 minus 3 e raised to x, and the common factor is at the beginning. Well, so we have already found our derivative. Now we should not be deviated from the question. Let us see, the question told actually to find the exact coordinates of the stationary point. So once again I am repeating that for stationary point the derivative is equal to 0. We have found already, find first derivative f prime x. So we have already got the first derivative, and they told to find exact coordinates of the stationary point. Remember, the relationship between stationary point and first derivative is 0. That means for stationary point, either stationary point or maximum point or minimum point, our derivative will be 0. So we have written here that our for stationary point, first derivative is equal to 0. And this is what our first derivative is. We have got our first derivative is 2 e raised to 2x into 4 minus 3 e raised to x over e raised to 2x minus 3 e raised to x plus 2 whole square. Just I have copied this over here. Yes, it is equal to 0. This is our first derivative. I have just copied from that step, equal to 0. So if it is 0, after doing cross multiplication, what will happen? If it multiplies, it is multiplied by 0, it will be 0. We have written 0. And here there is 1 as denominator. By 1, if we multiply this function, the upper function or numerator, it will be 4 minus 3 e raised to x. Now you may ask a question. It is not, this is 0, we believe this denominator has been turned to 0, but the question may arise that it is not only 4 minus 3 raised to 3 e raised to x, it was along with actually this. Where has it gone to? I have explained very shortly that look at this, either this equal to 0 or this factor is equal to 0, but no way any exponential function can produce 0. That's why simply we have written here that exponential function is always greater than 0. That's why it cannot be 0. We have avoided this. Well, so I think you got this. Once again, I am letting you know that this is exponential function. So exponential function can never be less than 0. It's always greater than 0. That's why only this is the factor which can produce, which can be 0. So we have written 4 minus 3 e raised to x is equal to 0. That means 3 e raised to x is equal to 4. If we transpose this to the other side, then e raised to x is equal to 4 over 3. After that, what have we got? We have e raised to x is equal to 4 over 3. For any exponential function, we will borrow ln. If we borrow ln on both sides, we have borrowed on the left side, this ln has been brought at the left side as well as the right side, and we know that a concept ln e is equal to 1. Okay, so ln e, this is equal to actually 1. That's why there remains only x is equal to ln 4 over 3. This is what our x coordinate. Okay, but the question told, let us see the question once again. The question says to find exact coordinates of the stationary point. So stationary point, suppose this is a point, let it be this way. So though the function will not look like this, for your understanding I am just explaining this. Suppose this is the maximum point. So for this maximum point, it doesn't mean that only x, the coordinate of x. This means x coordinate as well as y coordinate. So far we have obtained the x coordinates. So substituting these x coordinate in the function, in this function, we will find the y coordinate also. So let's go to our solution. Well, I have written here that x is equal to ln 4 over 3 when y equal to. So y equal to the function, we have just copied the function 2 e raised to 2 ln x. This was our x. Okay, this is our x. We have just substituted x everywhere. Okay, then what is it going to be? Let us see. It is here 2 e raised to ln 4. You know this, if I show you more clearly, these two, this two is actually the exponent of this. Okay, so just we have written it as exponent. Here we have written as exponent, this two has been written as exponent over here. Same goes here also. There was 2 here, this two is the exponent over here, and here there is nothing in front of this loan. Here there is nothing, so we don't need to write anything. Rest of the part is unchanged. Now already we have come to know that e raised to ln is equal to 1. E raised to ln is equal to 1. Okay, e raised to ln or ln e, both of them, or ln e is equal to 1. Okay, e raised to ln equal to 1 or ln e is equal to 1. So please keep this concept in your mind. So as this is 1, if this is 1, we will have to multiply this 2 into 4 square. 4 square means 16. We have written 16, and 3 square means 9. Same goes in the denominator also. This is actually 1. So there remains only 4 square over 3 square means 16 over 9. Minus here e raised to ln is 1. So 3 into 4 over 3 plus 2. This 2 is unchanged. So what are we going to get? The numerator is 2 sixteens are, how much is this? 2 sixteens are 32. We have written here 32, and this 9 is unchanged. So 32 over 9, the numerator is 32 over 9. This one is the numerator. And denominator means this portion is in division form. This is divisor. That's why we have used division symbol. This is 16 over 9. We have written here 16 over 9. Then minus, if 3 dissolves this 3, there remains only negative 4, then 2. So negative 4 minus plus 2 means negative 2 actually. If we copy this on the right side, I have shown it is actually 32 over 9 divided by 16 over 9 minus 4 plus 2. So if we look at this, this is negative 2. Okay, so 9 fours are 9 fours are 36. So negative 36 plus 9 twos are 18. Okay, so it is actually 16. Look, it will look 16 minus 36 plus 9 twos are 18. Okay, so what will happen? Negative 36 positive 18 plus 16 means 34. So I have written here that it is 34 minus first fraction is unchanged. In the second fraction, 34 minus 36 means it is going to be uh, or if you write it in another way, it may be 32 over 9 divided by numerator is what? Negative 2 over 9. So this division symbol has been turned to multiplication symbol, and the immediate next fraction has been reversed. It has become reciprocal. So it has become 9 over 9 has gone up and 2 has gone down. Then if this 9 dissolves this 9, they go away. That means 32 over 2 means negative 16. So this is our y coordinate. Okay, and our x coordinate we have already obtained, ln 4 over 3, and x coordinate, y coordinate is negative 16. So this is the stationary point of this function, and that is the final answer we have got. For the last moment, I'm going to show the whole solution together. This is the whole of the solution. At a glance you can have a look at this. So what have we done? Our question has told us to find the stationary point. Ultimately we have got stationary point. So the concept we have learned from this question, whenever stationary point, either stationary point or maximum point or minimum point is mentioned, then we will have to find the derivative, first derivative. So first derivative is 0 in case of stationary point. Then if we solve this equation, we find that our x coordinate is ln 4 over 3. Then substituting this ln 4 over 3 in the function, we get the corresponding values of y. Then ultimately we have got that our the stationary point, the coordinates of the stationary point is this ln 4 over 3 minus 16. Let's see what the question number B says. B says use the substitution u equal to e raised to x and partial fraction to find the exact value of integrand ln 3 until ln 5 of function of x. So function of x is known to us. So there are two parts. One is u substitution. They have already mentioned this, u equal to e raised to x, and then partial fraction. So these two parts are hidden in the same solution. Let's start the solution. First we have written here that ln 3 until ln 5, an integration of function x. then we can write the same function. The function was actually 2 e raised to 2x, and this is the simple function. Remember, not neither a derivative nor anything else. It's the function actually. Okay, the simple function. The question is 2 e raised to 2x over 3 e raised to 2x minus 3 e raised to x plus 2. Now they have told that to apply u substitution method, they told u is equal to ex. So we have written u equal to ex, e raised to x. Then we have differentiated both sides, because look, whenever u substitution occur, remember, in case of u substitution, always you will have to find u, and the immediate next part is to find derivative of x dx. So whenever we get u, whenever we assume any function as u, in case of u substitution method, then we must not forget to find ex, I mean dx. Dx should be obtained. So how can we find dx? If we differentiate both sides, then we will get dx. So here on the left side we have just written here. So on both sides we have brought du over dx. Okay, and you know the derivative of ex, just from the previous question we have come to know that derivative of ex is same, because we just differentiate the exponent. Exponent is here 1, I mean the derivative of x is 1. So if we multiply the exponential function by 1, it will remain as it is. So on the left side it is du over dx, on the right side as it is. Then we are actually trying to find dx. Look, this is the part. In u substitution method we should not ignore dx. So dx is equal to, if we do cross multiplication, let me erase this unnecessary part. If we do cross multiplication, then it will be, what will it be? Dx will replace e raised to x, and e raised to, they will mutually replace each other. E raised to x will come over here. So dx is equal to ultimately we have got du over dx. Okay, so du ex is equal to e raised to x is equal actually our u. So we have written du over u. So don't get confused that we can dissolve this u by u. That is absolutely wrong concept. Not at all, because this is the derivative of u, and this is only function. So please don't make this mistake that just cancelling the u, they look similar. They may look similar, but they are not same uh, as it seems to be, because the numerator is derivative, denominator is only function, which are absolutely different from each other. So we cannot dissolve here. So I think you have understood the how we can find dx. So dx should not be ignored. Once again, I'm repeating, whenever you apply the u substitution method, in u substitution method, always we will have to find dx. Okay, by derivating both sides, we will isolate dx. Dx is a must to be obtained. Okay, then we will have to apply whether we will have to find the limits. Okay, x, the lower limit of x, let us see from the upper part. Our lower limit of x is this. Okay, because this has been here, there was dx. Okay, so our lower limit was what? Ln 3, and upper limit was ln 5. So let us see, if x is equal to ln 3, what will be the corresponding value of u? Because x has been, there will be no more dx. Dx will be substituted by something. Now their limit should also be redefined. Well, so let's see, when x is even in terms of x, it was ln 3. Now what will it be in terms of y? Let's see, here we have written, when x is equal to ln 3, x equal to ln 3, when u is equal to e raised to ln 3, because u was actually what? E raised to x, isn't it? So if x is ln 3, u will be e ln 3. Instead of x, it will be ln 3. Well, and we have come to know that e raised to ln means 1. So u equal to actually 3. Same goes for the upper limit. Upper value was x raised to ln 5. So u will be e raised to ln 5 means this e and ln they will dissolve each other, equal to 5. So when the lower limit is our 3 in terms of u and upper limit is 5, that's why we have written here. So our the function is now lower limit is 3. If we substitute x e raised to x to u, then what will happen? Our lower limit was, we have already just found the lower, in terms of u our lower limit is 3, in terms of u our lower upper limit is 5. So we have written upper and lower limit, and this one, this is our in terms of x. So 2 e raised to 2x means 2u square, because let me show you, e raised to x, e raised to 2x, e raised to 2x can be written as e raised to x square. You know this concept. This is, both of them are exponent. So e raised to x is what? U. Okay, e raised to x, we have substituted e raised to x is u, and this square, so it is ultimately e raised to 2x means u square. That's why I have written here e raised to 2x. This 2 is unchanged, this 2 is unchanged. E raised to 2x means u square. I think you have understood, but I'm letting you know once again, it is e raised to 2x, e raised to 2x. So e raised to 2x can be written as e raised to x whole square. Okay, e raised to x whole square, and e raised to x is our u. Okay, then square. So ultimately e raised to 2x is our u square. So instead of e raised to 2x, I have written here u square. There is nothing else in the numerator, and in denominator there is e raised to 2x. E raised to 2x means our u square, minus 3 e raised to x. 3 e raised to x means x, so 3u plus 2. And this one of the most important part of this, we have already obtained dx is equal to du over u. Let me show you again. From the upper part we have found, look at this, dx is equal to du over u. Okay, so we have substituted everything, that means everything has been converted to u now. No more x at all. Let me erase all of these unnecessary parts. I think you have understood, as I have told, that u raised to 2x is u raised to 2x is u square. So 2u square. I have written here 2u square. Same goes here also. E raised to 2x is u square. Then minus e raised to x. It is not 2x. It is only e raised to x is 3. Then plus 2. And this is the dx has been substituted as du over u. So let's see the next step. The next step is over here. I have written here these two. Look at this. In the numerator there was a 2, isn't it? In the numerator there is a 2. This 2, these two can be written at the front. In the front we have written these two. So what does remain there in the numerator? And we can do another cancellation. Here there is u. Look at this. The denominator is u. These two can be written at the front, and what will happen to this u can dissolve this u, then there remains only one u. So ultimately 2 will be written in the front and u will remain on top. So we are going to write u on top. Okay, so there is u on top. Numerator is only u, and denominator is u square minus 2u minus, there was minus 3u. We can resolve this into factors. Look at this portion. I think this is not a big deal for you. You know how to factor this. I have just written, I have splitted this 3u into negative 2u minus u. That is, so if we, this is factoring rules, you know how to find the factored form. I have factorized here. So u square minus 2u minus 3u, this 3u has been expanded as minus 2u minus u. So from the first pair you can see that there is, in this pair u is common. So if you take u common, it remains u minus 2. From the next pair, if you take negative 1 common, you will get u minus 2. So between these two function, u minus 2 is common. This u minus 2 and this u minus 2. If you take u minus 2, there remains only u, and from the second function there remains minus 1, so we have written u minus 1. So this is actually our ultimate function given, converted into u. And we should not forget one more thing, I forgot to write here. Look at this du, look, because we are finding the integrand in with respect to du, so du should not be ignored, it should be continued everywhere. Here it will be du, okay, and same goes here also du. Well, so this is what, this is another step. And if we go back to our question, they have already told that you will have to use partial fraction. This is another concept, partial fraction. This is a concept which is interrelated to integration. Okay, so partial fraction means whenever we find the denominator is complex function, means in multiplying form or a large function, then partial fraction should be applied to isolate them. Look at this, there are two functions together, they are in multiplying state in the denominator. In such cases we will have to find the partial fraction, that means this fraction should be expressed in partial form. So how, what is the method is, this is our function, okay, this is our function. We just have isolated this denominator. First we have written a over the first denominator, I mean first factor, plus b over the second factor. Then both sides of this equation, this is an equation, okay, this is, sorry, this is an equation, this is our left side and this is our right side of the equation. Now if we multiply both sides by this denominator, if we multiply both sides by our denominator, then this will go away. On the left side there will remain only u. Look, again I am telling, suppose here there is something 5 over 3x. Now if we multiply by the denominator, then what will remain there? Look, this 3x will dissolve this 3x, then there will remain only the numerator. That's why on the left side there remains only the numerator. Let's see the denominator, right side. In the right side, a will multiply this and b will multiply this. If we multiply this, or I can explain, our a over, look at this, a was what, a over u minus 2. Now if we multiply this one with u minus 2 into u minus 1, u minus 1, look at this, we have multiplied by this, let me show you, we have multiplied by this, whole of this denominator is being used for multiplication. On the left side I have already make you understand that if we multiply by this, then this will go away, there remains only numerator. But what will happen in right side, in right side, look at this, what will it be if we multiply this function with u minus 2 into u minus 1, then what will happen, this u minus 2 can cancel out, so it is going to be a into u minus 1. Same goes for b, if we multiply b, it was u minus 2, okay, so if we multiply by u minus 2 into u minus 1, what will happen, this u minus 2 can that is sorry, this is u minus 1, so it will be this is u minus 1, so u minus 1 will cancel out this u minus 1, what will remain, it will remain b into u minus 2. Just this simple concept has been applied here. So if we multiply both sides by this denominator, there remains u on the left side, on the left side there is u, on the right side a into u minus 1 plus b into u minus 2. Now if we suppose that our a is, look at our u, you can convert it or you can term it as an equation number 1. Suppose this is equation number 1 or 2, whatever you tell. Suppose this is equation number 1. In this equation, if we apply u is equal to 2, what will happen? On the left side there was 2, this is the left side, so left side is 2. what will happen to the right side? This u, suppose this is 2, okay, so 2 minus 2 is 0. That means b into 0 means 0. But here what will happen, this is 2. If it is 2, 2 minus 1 is equal to 1, so 1a, this is 1. On the left side, look at this is only u, so left side is 2. On the right side, suppose u equal to 2, we are substituting the factor, the root of u, okay. So if u is 2, then a will have only 1a, plus here 2 minus 2, this is 0, so there will be no b at all. So a plus 0, that means our a is equal to 2, we have got a. Then if we suppose u equal to 1, now u is equal to 1, so what will happen, this is 1, this is also 1. On the left side also this is 1, okay. So the left side is 1, on the right side what will happen, 1 minus 1 0, so the first one is 0. And what will happen here, 1 minus 2 is negative 1, so it is negative b, okay. On the right side it will be 0 minus negative b, that means b is equal to negative 1. So our a is 2 and b is negative 1. Just we will substitute these values. Let's see our function. So our function we can write here hence hence this was our function, this was our actually expression which we are going to integrate. So our this function has already, we have found that our a is 2 and b is negative 1, so we have written individually. Let me show you once again. Our function was what, this was our function, look at this this is our function. That means our this u over u minus 2 into u minus 1 is equal to a over the first factor plus b over the second factor. So we have got a is our 2 and b is our negative 1. So just we have written 2 over this equal to, this function is equal to 2 over u minus 2 plus minus 1 over u minus 1, just the same thing. Yes, this is, so we have written this is equal to the, if we split this fraction partially, then it can be it was our a, it was our a, it was our b. So a and a has been replaced as 2, we have already obtained. So 2 by u minus 2 minus 1 over u minus 1. This is how we will convert a function or fraction into partial fractions. So this is the second part of our solution as per the instruction. So what are we going to do? We are just now individualizing them. Look, this is actually integration by parts. We are going to do integration by parts. So there are two parts, I mean two functions, okay. So individually we are writing. First we have written this one, these 2 2s are 4, isn't it? So this can be written as these 2 2s are 4, these 2 2s are 4, we have written here 4. And the function, this one, if 2 goes away then there remains only, this is our first part of the function. And here there is nothing as this one, look, this one is common for both of them. So we have written here minus 2, means this is common for both of the function. Let me show you again. And just we have written individually, but this part, this integration part and limit, it is for common for the first function as well as the second function. So we have just written individually. Look at this one is the first fraction and this is the second fraction. In between them there is minus symbol. So first fraction 2 2s are 4, but for the second one, it, as there is nothing in the numerator, so it is 2 into that is limit is 3 until 5, 1 over u minus 1. I think you can understand that this is nothing but individual writing. We have written them individually. There are two fractions have been written individually with this notation, okay, integration notation. Well, now we are going to integrate finally. Look at this if we show you that, suppose there is a function as we are integrating 1 over x. Integrating 1 over x is actually integrand of 1 over x actually ln x plus c. Okay, ln x is, suppose here there is dx. So uh, any inverse function, if the exponent is 1 or negative 1, then actually 1 over x means it is ln x. So integrand of 1 over x is ln x. That means instead of x, if there is something else, it will be just inside the ln. Okay, so once again I am repeating, the integrand of 1 over something, 1 over any function is actually ln function. That's why we have written here, this is actually 1 over, our function is 1 over u minus 2, 1 over u minus 2, this is our function. So this equal to ln u minus 2. So 1 over x is equal to ln x. So 1 over u minus 2 means ln u minus 2. Same goes here also, this is 1 over, suppose this is the numerator, instead of x the function is u minus 1. Okay, so 1 over u minus 1 is equal to, this 2 is unchanged, this 2 is unchanged. Then ln u minus 1, ln u minus 1. So 1 over x is equal to ln, that means integrand of 1 over x is equal to ln x. So instead of x we have substituted u minus 1 and u minus 2, and this 2 is unchanged, this 2 and this 4 are unchanged. And the limit, what happened to this limit we have written over here, 3 until 5. These are the limits we have written here, 3 until 5. So ultimately what have we got? We have got that the first part is this, first part is up to this 4, yes, 4 ln u minus 2, and second one is this. Okay, now we will substitute the values. Look, this limit has been given, limit of the variable. If u is 5, what will happen? 5 minus 2 means it will be 3. Okay, if u is 3, then what will happen? If u is 3, 3 minus 2 is equal to 1. So it will be actually ln 3 minus 1, ln 3 minus 1. And what will happen here? If this is 5, this is 5, then it will be ln 4. Okay, if it is 3, what will happen? If it is 3, it will be 2. So ln 4 minus ln 2. Once again I am repeating, suppose this is 5. If it is 5, what will happen? 5 minus 2 is equal to 3, so it is ln 3, upper limit is ln 3 minus lower limit. If it is 3, what will happen? If it is 3, 3 minus 2 is equal to 1, so ln 1. That means it will be over here, first if we substitute 5 upper limit, it will be ln 3, then it will be ln 1. Same goes here, the first one was ln 4. Let me show you, the first function was ln u minus 2, u minus 2. Okay, so if u is substituted by 5, so it will be ln 3. Then if u is substituted by 3, now if u is 3, then what will happen? 3 minus 2 is equal to 1, we have written ln 1. Second function was ln u minus 1, second function was ln u minus 1. This is the second function. For second function, suppose if this is 5, u is substituted with 5, then ln 4, 5 minus 1, 4. If u is 3, what will happen? It was 3, because lower limit was 3. You should not forget, lower limit was 3, upper limit was 5. Okay, the values ranging from 3 to 5. So if it is 3, 3 minus 1 is 2, so second function will be ln 2. Okay, I can show you the previous part. If we zoom it in, we have just substituted this upper limit and lower limit. This value has been substituted. If this is 5, look, if this is 5, so 5 minus 2 is 3, we have written here 3. If we substituted by 3, then it will be 3 minus 2 is equal to 1, so we have written ln 1. Same goes here, if it is 5, upper limit, 5 minus 1 is 4, we have written 4. Then if we substitute by 3, then 3 minus 1 is 2, we have written 2. So what will it be? Ln 1 is actually 0. Okay, so if we multiply, it is 4 ln 3, and 0 4 zeros are 0, we avoided that. Then here ln 4, if ln is taken common in case of subtraction, this should be division. Okay, if we do subtraction of ln, then taking ln as common, it is division. So 4 over 2. So what is it going to be? Actually equal to, it is ln 3 raised to 4. This is actually exponent. This coefficient is the exponent of this, and this coefficient is the exponent of this function. Okay, the first coefficient is the actually exponent of the log function. Well, so 3 raised to 4, this is 3 raised to 4, and this is going to be 2. If we dissolve this 4 by 2, it's equal to 2, and this 2 is actually exponent, so ln 2 square. Okay, this is actually ln 2 square. Now if we take ln common from both of the function, what will happen? It will be 3 raised to first function. In subtraction, what does happen? It is in subtraction of ln function, it is actually division. So we have taken ln common, then this one divided by this function. So 3 raised to 4 over 2 square means ln 3 raised to 4 means 81, and 2 square means 4. So that's all our the integration. I think you have understood so long. So here two concepts there were. One concept was that u substitution. In u substitution, we should not, let me erase whole of the part again. So the question has told us to apply u substitution method, and then the another one is partial fraction, use substitution method and partial fraction. So the question sought two parts, but there are so many hidden parts inside this. First of all, look, whenever use substitution is applied, we should not ignore the value of dx only. Not only you will have to obtain the value of corresponding value of dx. That's why first of all we have found the value of dx. Then the second part is the limits. Look, the limit was ln 3 until ln 5. Okay, this limit has been given in terms of x. As we are converting everything to u, we will have to find the lower limit and upper limit, because this is integration with limits. Well, so we have got the limits. Once again I'm repeating, for u substitution, we will first will find the derivative of x, I mean dx. Then we will find the lower limit, corresponding lower limit and upper limit. After that, one more part is hidden here, that is partial fraction. In the partial fraction, first the denominator should be factorized. After factorizing, they will be written individually. It will be equivalent to the number of factors. If there are three factors, then you will have to write c over the another factor. Okay, as there are two factors, so we have written only a and b. After that, we have substituted. After isolation, we have got these are the function. Then we have substituted the values, the upper limit, lower limit, as per the knowledge we have about integration. So that's all about the solution. I think you have understood as per my explanation. And if such solution makes you benefited, then I am grateful to Almighty Allah, Alhamdulillah. And I can make a request to you all. If you think that any particular problem should be solved from the past papers, from either a IGCSE O level or A levels, then please send me that question along with the session, that means the proper question, through WhatsApp. I have already shown you the WhatsApp number at the beginning. My WhatsApp number is over here. You can please send me a text about any particular question. If you face problem to solve this, then I will try my level best to explain that in a very convenient and easy way. Allah Hafiz.